All right, so today I'm going to introduce you to a new model we're going to start using for some labs we do in class. This model is called Argument-Driven Inquiry, which can be ADI for short. So we're going to start using ADI this week, and I want to start by just introducing to you what it is and what are the steps we follow in ADI. So first of all, ADI is a relatively new model that we're starting to use in US education, and it has a lot of parts to it that really help encourage science literacy. So to really help you guys understand more about what science is like in the real world. So there are four big focuses of ADI. So the first one is to know important scientific explanations about the world, use these explanations to solve problems, and understand new explanations when they are introduced. The second focus is to generate and evaluate scientific explanations and scientific arguments. The third focus is to understand the nature of scientific knowledge and how scientific knowledge develops over time. And the fourth focus is to participate in scientific practices as well as communicate in a scientific manner. So in order to help us work on all of these skills, ADI has made 8 steps that we will follow when we do our experiments. So I'm going to go through these 8 steps with you, and then over the course of this week, we will actually do all 8 of these in class. So step 1 is identification of the task and guiding question. Also during this time, I will do something called tool talk, and I'll just show you how to use any sort of equipment or tools needed for the lab of the week. This is also an area to get like tips and hints of how to set up your design. Step 2, designing a method of collecting data. So instead of just having directions of step 1, do this, step 2, do this that I make for you, the goal of this is you're going to actually design your own method because science in the real world forces scientists to actually design that method. Okay? And so when you're designing your method, you need to be thinking what data is needed to answer that guiding question. And so when you keep that in mind, that'll be how you determine, well, what am I going to actually do to generate this data? Step 3, data analysis and development of a tentative argument. So after you do your experiment and you collect your data, we now have to look at it and we have to make sense of the data. And you're going to develop a tentative argument or an explanation to that guiding question. So there's going to be 3 parts. You're going to 1, make a claim, 2, use evidence to support your claim, and 3, justify how your evidence is actually supporting the claim. Step 4 is an argumentation session. So you will share step 3 basically with your peers. So you're going to share your claim, your evidence, and your justification. And then you'll also see what your peers are doing and you will evaluate each other. And then you'll go back and revise your tentative argument. Step 5 is explicit and reflective discussion. Okay, so we will talk about our learning experiences. We will reflect on the strengths and weaknesses of your experiment and your experimental design. If you go around the room and you see everyone has roughly the same data, but you, this is like that moment that we'll reflect and discuss on it and like, where did you go wrong? Maybe you're right and everyone else is wrong. So we'll have that discussion. We can also talk about cross-cutting concepts. So concepts that you see in all of your science classes. And then finally, we'll talk about the nature of science. So at the beginning of the year, we went through the nature of science and all of those different characteristics, like how it's tentative and how there's multiple ways to collect data. So we'll go through that also. Then in step 6, we write the report. And the report is just short and sweet, but we're going to mainly cover what question were you trying to answer and why, what did you do to answer it and why, and then finally, what is your argument? What is your explanation? Step 7 is a double-blind group peer review. So double-blind means you don't know who has your paper and they don't know whose paper they're looking at. But then they're going to read through your report and they will give you feedback. And that brings us to step 8, where you'll revise your report based off your peers' feedback, and then you will turn in that report. So by doing this, it's a much better picture of how science actually works in the real world, rather than just giving you a couple steps that I make and have you follow some steps, look at some activity, and answer some follow-up questions. So the whole point of argument-driven inquiry is to really develop your scientific thinking skills, your scientific reasoning. It helps you practice the actual behaviors of scientists, and you also practice this argument session. And I think that's important to note, because in science, we don't know the ultimate correct answer. We don't know who is correct. And so scientists do spend a lot of time arguing and justifying who's right on our topics. And so we're going to start this week, and follow along for the next videos to learn more about our upcoming lab for this week.